And welcome to Data Science 101 using R uh, module. So this is the part of the series I started last year about data science. I just touched base a little bit fundamentals using Python. In this session, we'll talk about data science, machine learning, and do some side-to-side comparison between R and Python. And before I begin on this, I would like to touch base a little bit upon the fundamentals of data science. It won't be too much theoretical, just more of a practical how it evolving in past couple of years. So coming back to data science, so is data science is nothing new. It has been there for like I think 30 years, and first time the paper was published during 1960s, and Peter Naur was the one who actually used as a programming model. So data science is actually, if you want to see a definition, it is a concept of unifying statistical data and into a related data model so that you can understand and conceptualize the data. What does it mean? It means that you have data. This again, this is coming from a statistical background. This is nothing new. So it has always been there in a where if you're doing a mathematics course or doing a PhD in statistics. So these people were specialized doing, like, they will model, they will analyze the data, and based on the data they will create some kind of models and algorithm, and based on that they can actually predict some behavior. So this has been heavily used in clinical research and other kind of activity where they do a drug analysis, and based on the drug testing they will come up with, okay, and now they take the data set of a drug testing, and based on that they will run a model and to see which drug is better. So these are the very standard statistical use case about the data science. This has been there as a statistical analysis. So what happened recently? Recently, what happened, like past, like I will say about 10 years ago or maybe in few decades, the whole landscape changed when these Silicon Valley companies like Google, Facebook, and they use these same principles and were able to monetize this user data, behavioral data, and the social media data to a massive multi-trillion-dollar industry. They were able to very efficiently monetize this data using these data science principle and machine learning tools, and that is how it changed everything since then. So now more and more enterprise, everybody wants to understand data, because earlier how the marketing approach has been, so one marketing guy says, okay, let's try this, let if it works or not. But with that new model, which has become a data driven model, what happened was, now people do not decide at random any kind of marketing strategy. What they do, they monitor the user behavior, and based on that behavior the data model itself predict what could be the next thing. Take an example. If I'm doing a Google search on say homes near Toronto, and now based on if Google has a tie-up with a local bank for data sharing or something like that kind of agreement, so they can share the data with the bank, and bank will come, okay, oh, this guy is looking for homes, so maybe he was looking for a mortgage. So actually the bank can proactively approach me and say, okay, you have pre-approval mortgage for this low interest rate, whatever it is. So this is the different, so now the marketing and the business change from being reactive to a more proactive approach. So now you see the behavior of the user, and based on that you can predict his next action, and you can actually make a business move, and that can be very beneficial, and that has been a tremendous success in Silicon Valley. And on the other side, this whole so again, because this has been already been there, and even while doing engineering we learned about these tools like MATLAB and SAS, and these tools are actually, they are great tool, but the other thing is they are extremely complicated. Even to learn a basic hello world kind of in MATLAB and SAS, for a college student it will take maybe months or weeks before they can actually do something. Forget about making some real business case. It will take probably years. If you do your whole graduation and PhD, then you'll be able to do some data modeling using these complex tools. I'm not saying these tools do not have place. Yes, they do have, but with the advent of these technologies with big data, this whole thing has been commoditized. So now you have more easy to use tools which you can use for data analytics. So before then, say as you mean maybe 10 years ago, you need to have a PhD in data science or statistics or mathematics in order to do some kind of a modeling. But nowadays you can have a basic understanding of mathematics, and you can use modern tools like R or Python to get some basic definition, because majority of the algorithms and models has already been developed. Nowadays what you have to do is you have to apply right model to the right data set. So as long as you understand these kind of things, you can do some bit of data science by yourself and in most of the business use case. So as we talked about how the business real use case changed. So when we are talking about the data science, why it is there and how it is there. So the whole thing comes around that how a company can use the data. Say, take an example of a Google or any internet company, how they use the data and transform into a useful information. So it involves a lot of take an example of your data. Say you're doing Google search, and now your search data is very unstructured data. You're doing this, and then also it's not only one data that you're using. You'll use your Google search data, your Facebook behavior, what you're sharing with your friends, and your geolocation, where you're going. So say if you're looking for a home, so probably you will be talking to your friends in a Facebook or sharing something, searching Google, and then you may be traveling around to see some houses. So all these three data sources need to be combined, which is like aggregation, like acquiring the data. They need to be aggregated, and then on these data, because these are all very different structured data. Facebook, they have own, and mostly these data are all maybe a NoSQL kind of data or JSON data. These data need to be acquired, and then they need to do some kind of data preparation so that you can build a relationship between these three data sets. And based on that, this is called the data preparation step. You are actually wrangling the data, cleaning the data, transforming the data. And then once your data is completely clean, at that point of time, you can actually use those models and algorithms, because all the statistical models and algorithm, they work on data, like they need numbers like how many. So you have to normalize the data, or somehow all fundamental principles are still there, but it is how you do it, the way is changing. So you once your data is in a number format, so that it can be, then it is useful for a statistical model. Then you apply the algorithm on it and you get the data out of it. So this is what I just explained. It is called a typical data science pipeline, or any pipeline. Now if you go to anywhere in the enterprise, everybody is doing the same. And again, this is nothing new. It has been there for decades and decades, but this thing has been a very specialized skill. Couple of years ago, you need to have a very highly educated in the mathematics in order to understand it. But now with all these modern tools, majority of job is already done by these applications, and you just have to understand the concept. Concept understanding is very important, and you have to apply the right principle and right model to the data. So what we did is data pipeline, and assume this is what you're doing. You get an analysis, and if anybody from engineering background, they know, they have studied control system, which is like a open loop system, closed loop system. So if you take this whole pipeline and make it a closed loop system, which means the difference of the data, whatever the outcome is, if you feed it back to the acquiring phase, you can actually make a closed loop system, which will like a self-healing system, which means you can actually make it a self-predicting. So this is what it is. I mean, if you're talking about from a layman point of view, what is machine learning? You take the same data pipeline and you apply some kind of feedback. Based on that, it learns from itself, which is basically, and a lot of words are being used, but they have been in our field for a long time. So it's a closed loop system. You tell the model how to behave. Oh, your data had this much error. You keep fixing the error, and then you create a system which is self-learning, which is like closed loop system, self-learning, and it calls a machine learning. So if you make the whole data pipeline end-to-end automatic with a closed loop system feedback, you have a machine learning. Although it sounds very easy in this in these diagrams, but in theory it may sound like, right now it sounds very simple in a diagram, but it is extremely difficult to implement. because there are so many moving parts, so many different technology stacks, and a lot of mathematics involved, and not everything is actually quite open that you can use it. So this is the whole crux of it. So going back to this data science, let's talk about some the technology stack. So that was the theoretical concept I was talking about, and now if you come to the technology stack, just want to show where everything fits. So if you're talking about the legacy style, by no mean I'm saying they do not work or they are not as good as. It's just these technology stack has been used by enterprise for decades, and they have been leader in the market, and they are still being used majority of the cases. But so legacy stack looks like that. You have application which is mostly doing inserts, SQL statement or SQL, or maybe dumping CSV file. They take those kind of data inputs and use data preparation, which is they call ETL tool, like extract, load, and transform. So using these ETL tools like IBM Data Stage or Talent, they take the data and massage the data. A simple example of data preparation, I could say that it's a date format. So assume say Facebook uses one type of date format, Google uses a different type of date format. If you want to aggregate or combine both of them, it won't work till you actually make all of the date format into a single format which is common across the system. So this is one way of doing transformation. So if someone is talking about transformation, pretty much they are actually changing the data set so that they can be used in a single way. So this is called data preparation. And once the data preparation is done, you get the data, and the output can be now used in any kind of thing. And Excel being one of the very popular, and a lot of people won't say it, but majority of the market still they are using Excel sheet. Business is heavily used by business. They are using Excel sheet for everything, and Excel has a lot of advanced feature to do that. I'm not an Excel expert, but yes, Excel is heavily used. And if you're going one more step, people are using SAS. SAS has been in enterprise heavily. And also the machine learning tool, there is called IBM Watson, which is very cool. If you can actually play with it. You can just upload a CSV file, and based on the data, it automatically tells you a suggestive. I won't call it like complete machine learning. I will say it is more of a like interactive, suggestive way. So if you load a data, it says, okay, you're looking for this. If you click it, it gives you a very nice graphical way. And after analytic, you have a graphical GUI phase, which is like you may be using Tableau or IBM Watson can also be used. And then again, the data science, the big data stack. The big data stack is it gives you the same solution, but the approach is very different. So if you want to talk about like big data, you can check one of my another video. I talked about the fundamental of big data and a lot of confusion around big data and Hadoop. So I have explained that. So I won't touch here. I will just talk about the data stack. So you have big data. So big data, what it provides you flexibility. It's not like the legacy system didn't provide you solution. Legacy system was perfect and still working to date and very stable. But the big data, what it gives you more flexibility. Now you don't have to say, okay, my input data has to be SQL, my input data has to be CSV. No, you can dump any type of data, SQL, no SQL, your IoT data, traffic data, or any stream data. It doesn't have to be batch data you put at the end of the day. You can actually continuously feed to it. So you can have multiple way of data acquisition, which is like data ingestion. You can have batch, you can have a stream ingestion, which is IoT data, and then you can have a data preparation. So modern data preparation tool, you can use like a Trifactor Data Wrangler, or you can use Apache Spark. So Trifactor Data Wrangler, it gives you everything out of the box. So you hook it up with your big data, maybe Hive or any kind of data set, and automatically suggest you very interactive way for data wrangling. And if you want to do it by yourself, you can use Apache Spark. So it will involve some coding. You can use Python, Java, or Scala. And once your data is prepared and wrangled and everything, this is actually the majority of the part. Majority of the data science, actually they invest there almost 80% of the time doing this kind of thing. And then comes the data analytic. And data analytic, as I said, majority of tools and algorithms has been already invented, finished, application developed maybe 30 years ago. Now you have to do it. You have data preparation is done. You have to apply the right right data model. We once down the stream we'll talk about like box model, like box plot. Box plot is a way of showing how good a data is. So it's not like box plot you have to invent. This has been done already by academia long ago. You just have to use the clean data and call the function and boom, you got it. So it's no longer you have to write so many mathematical formula on the by hand to get that output. You have one command in R, it gives you the job. But I'm not saying this will be the real use case, but you can build more complex use cases. But again, the fundamental algorithm you do not have to define. It's already been done long time ago. So analytic phase, you can use a data robot, which is a machine learning tool, and you can use SAS or R, and you can use IBM Watson. So we talked about, let's talk about R. So what is R? R is actually a programming language. It was designed and developed by a New Zealand university, and it was designed specifically for mathematical work, like these kind of use cases of statistical analysis and mathematics. It has a lot of inbuilt mathematical function. So it suits very well into data science world. So you can use it for data preparation, you can use for data analysis, you can do for everything with the data. And again, do not confuse it with a general purpose programming language like Python or Java. If the syntax, take an example. If you want to create a matrix multiplication, probably it will multiple lines of code, or it may be a bit complex in a regular general purpose language like Java and Python, because the difference is that these programming language, the computer science language, Python, Java, they are designed to optimally use the data structure in a computer and give you efficient usage of CPU utilization, memory, and all these kind of things. But on the other side, R is designed not to too much care about the CPU and everything, rather to give more ease of use to the user who is an analytic guy, who is a mathematician guy. So they may not be very good at programming syntax and CPU and all these kind of things. What they care, they have the data and they want their model to be run as quickly and as easily possible. So the design goal of R and Python is different, completely different. And if you're comparing with them, it's not apple to apple comparison. But yes, whatever you can do in R, you can do in Python and Java as well. But again, for a Java or a Python, you have to hire a software developer, which will like cost additional. But for a data science, if he's doing something, or he or she is doing some work on their PC, they don't need to learn a general purpose programming language, because they're not going to develop a web application or something. They just want to get their math and done. So for that, R does the job, and it's open source and free. It works perfectly fine in all platforms. And it again, the SAS, again, don't there is no comparison, like they're complementing each other. So R is heavily used in academia and SAS is heavily used in enterprise, because many enterprise, they don't want to use any application which doesn't have a commercial support. So for that reason, maybe SAS, and also SAS has very good use cases for enterprise, which are like maybe proprietary, and they work very well for enterprise. But maybe in the R, you have to develop that whole thing. So both exist, and many times they complement each other. As a data science, it's good to learn both tools at the same time. So we'll take a quick look at the R. So before doing R, I just a little bit touch on the stats. So if you are doing any R, so you should have fundamental understanding of statistics. So like mean, median, mode, range. So what is mean, median, mode, range? So if you are not from background, you can Google it, or I'll just say it quickly. Mean is the data when you take, mean is the average of the data. So if you see my example data set, so my mean will be, I divide by 9, it will be 15. And median is the middle of the data. Middle doesn't mean it has to be the middle value. It is the index. So if my data is like 13, 18, whatever it is, so whatever the middle is coming, this is if I sort the array, and after that whatever comes in between or the middle point, it is my median. And mode is the most frequent data is the mode, and range is your data range, the whole difference from max to min value. And now this is your all this is your basic mathematics. And if you want to do same thing in R, so it makes it more easy. So if you want to use R, you can actually simply use a just download R. you can it's just one click install in all platform, Linux, Mac and Windows. And I would recommend to use RStudio because it's a more graphical user interface. It gives you a good idea of it. So the syntax we can touch base on, like if I go to the next one. So this is the RStudio, how it looks like. So the syntax of the R is it's a bit different. If you're coming from a programming background, like I am from a computer science background, so the syntax, if you see, is very different. If I'll do a side-to-side comparison of Python versus R to syntax. So take an example. I have here RStudio and I open a Python here. So if I want to declare a variable, I do this, but in R, the syntax is a bit different. I do like this, and I think yes. So this is how I get R. I type X, it shows me X, and this is X. So the syntax is a little bit different, but again, the design goal is completely different. You should not compare them one to one. This is, I'm just showing because a lot of people have confusion. If I'm doing data science, should I go with the R? Should I go with the Python? I would say if you are coming from a data background, like math background, you are probably already know R. If you are not, you should get into it. But if you are coming from a computer science background, Python may be easier because you are already used to doing it. But again, if I want to if I want to do a box plot, so I will not write a 20-line code in Python. I will just write a box plot function, and that's it. I'll get in R. So it's a different use case. So take an example. If I want to do, say this is my data set. Say I have a data set like, so data set you can pretty much create using C function. So you have this. So if I have my data set, assume like 1, 2, 3, 4, 5, 6, 7, 8, and 8. So I created the data set, it shows me, and this is what I just now created, is called a vector. Vector, it is used in a stats world, but if you are talking from a computer science background, I created an array, simple array I created. So if I'm doing the same thing in Python, pretty much I'll do this. Say x equal to I think yes, 1, 2, 3, 4, 5, 6. I do this. So they are the same thing. So if I want to access something, I do here, it's the array, any regular array, and here I created a vector in R. So the concept is very similar, but it is the different use case. But once you start using both of them, you will realize they are like way different things. They are not like, I heard some people are like have developed a web server using R. I mean, just it's for doing something, but it's not the use case for R. So say I have the data. Now if I want to get a mean, median, I just have to type like mean. That's it. Function is inbuilt, it gives me the mean. Boom. If I want to have median, it suggests me, I have see median. I can get mod. So it gives me everything very easily. And same way, if I say I want to create a box plot, I was talking about. So if I do box plot and I do X, I think box, yeah, see, it gives you a box plot. So box plot is one of the tool is used to say the quality of the data. Take an example, if two drugs are there, one drug is A, one drug is B. So many times the mathematician people, if you get the data from say drug test, so they do these kind of this is I'm giving a very fundamental example. There are more complex algorithms are there. They do Poisson distribution, a lot of things are used. So this is the tool. R will allow you, once you have the ready-made data, and you can must completely clean data, and then you use these kind of advanced function to quickly see and analyze your data, and based on that analysis you can say, okay, this data is good, this data. So if you are a data science in a pharmaceutical company, so most likely they will see that they will give you 5 results, and they will ask, tell me which drug will be successful in the market. So based on that, these kind of tools, you can say, okay, this data will be good, and you can say go ahead with that. So same thing if I want to do in Python. So I took example of, again, Python is so big, like, so they have like 200 types of libraries. So if you want to use Python, then I use this Python 3 library, which is called the statistics. So you can import this library, and this library gives you a R style thing. So you can do a mean, median, mod pretty easily using that. And this is it. So this is what I want to touch base on. Basic about the both of the difference. All details I have mentioned in the below, and if you have any question or anything, just leave a comment below, and you can check out on my website, our website, bcloudready.com. And thanks for watching.